Hello everyone. Today's course is very important. So I divide this course into two parts. The first part is about KVM I/O process, and the second part is about Huawei's Fusion Compute. Let's start the first part.
In this slide, we will talk about the I/O operation flow of KVM. We are talking about the computational virtualization. Unlike the problem when I/O virtualization is the difference between simulation and parallel virtualization. We are using the KVM I/O operation flow to solve the remaining problems by this way. By default, KVM's I/O operation flow uses an analog approach to I/O virtualization. The simulation method has to go through a total of 10 steps. The first step is that the virtual machine will initiate an I/O operating request. Then it sends a request to its virtual device driver. Then the I/O trap code inside the KVM module will capture this I/O request. After capturing, it will put this I/O request into the I/O share page. At the same time, it tells QEMU that we have an I/O request for processing here. Then, QEMU also goes to the share page of I/O to get the request. After getting it, it will take a close look at what the I/O request should do, then simulate according to the I/O request, and then send the request to the real device driver. The device driver then goes to the physical hardware to process the I/O request. After processing, QEMU puts the result in the share page of I/O. At the same time, it will notify the KVM that the request has been processed. Then, the KVM module goes to the share page and takes the request and returns it to the guest OS, so that the entire I/O request is completed. During the whole process, do you find a problem? Whether it is the guest OS or the I/O request or the result returned by QEMU, it must go through KVM. But the real KVM module does not do anything when this request happens. Is there any way, for example, my guest OS itself is a requester, then my QEMU is a processor? Can you let the guest OS and QEMU deal directly? Do not enter the KVM module. This fastens the process and improves performance. Consequently, programmers have developed another solution for this problem, which is Word.io. In Word.io, this request no longer passed through the KVM module, and the result returned by QEMU does not pass through KVM. They can only send a notification via KVM. Then, the result of this request and return is placed in virtual space. This eliminates a step like KVM, which improves the performance of I/O virtualization, which is parallel virtualization. How is the specific performance? Under the Windows operating system, you can see the rate of network cards, the speed of virtual machine network card. If you use Word.io, but to use the default I/O operation process, we see 100 megabit network card. If you use Word.io, install this after driving. The network cards we saw was 10 gigabit, which is the performance improvement.
Okay, everyone. Now we have finished the first two subsections of this chapter. And next, I will make an introduction to Fusion Compute.
When doing the experiment, we use Fusion Compute as a carrier. First, let's take a look at the architecture of Fusion Compute, which is similar to the architecture of KVM. It is also a management tool and then a virtualization product. The management tool for Fusion Compute is VRM. VRM can provide administrators and users with a graphical interface to the web. Then, through this interface, we can see the state of virtual machine, the state of virtual source pool, and the information of the physical hardware, the information of virtual machine, and so on. There is also a cluster. The cluster provides computing resources, storage resources, and network resources, and so on. All above are the architectures of the entire Fusion Compute. What are the specific advantages of Fusion Compute? First, it provides unified management of virtualization and physical resources. It can manage physical computing resources, such as CNA host can manage physical storage resources. Then it will add some storage devices. Then you can also manage the physical network devices, and the virtual resources formed by these physical resources can be managed. Second, through VRM, we can quickly issue virtual machines, copy virtual machines with virtual machines, and use the template to issue virtual machines. Finally, Fusion Compute consists of two major components. The first is CNA. CNA provides the following functions: provides virtual computing functions, manage VM on compute model, manage compute, storage, and network resources on compute nodes. The other one is VRM, which is a management tool. VRM provides the following functions: manage block storage resources in clusters, manages network resources, such as IP address and VLANs in clusters, and assign IP address to VM, manage the life cycle of VM in clusters, and allocate and migrate VM across compute nodes, dynamically schedule resources in cluster, manage virtual resources and user data in a unified manner, and provides elastic computing storage and IP address services. Provides a unified web UI portal allowing OM engineers to remotely access the Fusion Compute system to monitor and manage resources, and create some view resource reports.
Okay, everyone. All about are the contents of this chapter. Now, let's see two quizzes for review. The first quiz is, in compute virtualization, which of the following allocates CPU and memory resources to VM? The second one, all open source virtualization technology are Type 1 virtualization, while all closed source ones are Type 2 virtualization. Is it true or false? I believe you have known the right answer. Now, everyone, we have to do a summary. This chapter provides some basic knowledge about compute virtualization. And I introduce CPU virtualization, memory virtualization, I/O virtualization to you. And then I introduce open source virtualization to you by using KVM as an example. And at last, I introduce commercial virtualization to you by using Fusion Compute as an example. If you want to know more details about this compute virtualization, and you can find them on the following three websites. They are Huawei e-learning website and the Huawei support website and the HCIA Computing Online Forum. Okay, everyone. If you are getting interested in cloud computing, and you have to follow our course. See you. Bye.